Hello and welcome to our second lesson of the unit. We're doing Introduction to Scalars and Vectors. So, what's your learning goal for today? I can explain the difference between scalars and vectors, and I want you to be able to perform simple addition and subtraction. So, what are we talking about? These are new words for you, new terminology, so I want to compare scalars and vectors. All right, so let's keep it simple here. So, vectors and scalars. So you've worked with scalars. We're going to talk about it first. Scalar has magnitude only. Magnitude, and that's a fancy word for size only. So what are some examples of scalars? Well, when you're driving 30 kilometers an hour, that's an example of a scalar. All right. If you have a 2-liter bottle of pop, that's a scalar. If you have a mass of 30 kilograms, that is a scalar. Okay, so those all are scalar values. So the question is then, well, what is a vector? A vector has magnitude, so very similar. Magnitude again, fancy word for size, and direction. All right, and that is the difference right there. It has two things. It has both magnitude and it also has a direction tied with it. So for example, I could say I'm doing 30 kilometers an hour, and in square brackets I put my direction, east. Or I could put forward, I could put down. I can't put 2 liters in because the volume, you would never say 2 liters up or 2 liters sideways. So volume, I can't convert into a vector. Kilograms, I can change into a vector, but I don't want to do it right now because it's something that you're not familiar with. So I don't want to head in that direction. I could do a distance. I could do 50 kilometers south. All right, so very, very important, okay? So for a quick example, directions. When you give directions, you are giving vectors to whoever you're explaining it for, okay? You're using vectors. All right, if you're trying to give your friend directions, I live 20 kilometers from Mitchell, what that would mean to the person listening is that if this is Mitchell, all right, in the center of my map here, so there's Mitchell, I know that you live on this circle. You live 20 kilometers away. However, I don't know in what direction, and I have no clue how to get to your party. Okay? So that is an example of how you would use a scalar. Now, if you want the person to get to your party, you would say, I live, 20 kilometers east on Highway 8. So now, when the person is sitting here in Mitchell and they want to get to your place, they know that they take Highway 8 and they go a distance of 20 kilometers east on Highway 8, so you're heading towards Stratford. Okay, so that is the difference between, the simple difference between a scalar and a vector. If you give me a direction, you are talking in vector terminology. So what does a geometric vector look like? So geometric, fancy word for picture. All right, that just means picture. If you were to draw a vector for me, this is what it would look like. Okay, it is simply an arrow. We have our tail, that's our starting point. Okay, at the other end then, this is our head, and this is our end point. So it tells me, it indicates to me the start point, the end point, and the length you draw is your magnitude. So the longer the vector, the farther I have to go in that direction. All right. What is a resultant? A resultant is the sum of two or more vectors. Okay, so sum just means it's the result of adding two or more vectors together. So there is our terminology. We're going to draw those vectors, and you're going to add them up for me, and I'm going to show you the process in which we're going to do it. So here we are, adding and subtracting vectors. I've given you two vectors that we're going to add. Right here are the instructions. Determine u plus v. I could simply say, or find the resultant. All right. So steps. I'm going to give you the steps on this first example. First step, draw the first vector in space provided. And it doesn't matter which one. You can't mess this up. You can't pick the wrong one. So for argument's sake, I'm going to draw vector v first. So vector v, I'm going to go right here. So the tail there, it points down 1 square. So there is vector v. Okay, so it does not matter which one you pick. Here's the important step. Draw the other vector with the tail on the first vector's head. Vector's head. Okay, so I'm going to take my u vector. I see it starts here, and I got to go up 2 and over 1. So I draw the second vector right there. I'm going to go up 2 squares over 1. That's where it ends. So there's my u vector. All right. The resultant then, step 3, draw the resultant. Draw the resultant. All right. And then simply start to end. Okay. So I'm going to change colors. Here's where we started this journey. Here's where we finished the journey. There is my resultant vector, and we always use an R to indicate that it's the resultant. Okay? So step 4, find magnitude and direction of resultant. And how do we do that? We use Pythagorean theorem. And we use SOHCAHTOA. And we're going to do that every time. Okay? Every time we're going to use Pythagorean theorem and SOHCAHTOA. So to finish this example off, so if you need to write that down, pause it. Okay? So the magnitude of R. How do you use Pythagorean theorem, you're asking? Because you don't see a right angle triangle. We're going to create a right angle triangle. The resultant is always hypotenuse. Resultant is always the hypotenuse. All right? Always. So I'm going to create a right angle triangle. And it doesn't matter, I'm going to go this direction, for example. I know that it's 1 square in length this way, 1 square in length this way. So when I use Pythagorean theorem, a squared plus b squared equals c squared. It's going to be 1 squared plus 1 squared equals, and now instead of using c, we just use the r for r squared. 1 squared is 1, so 1 plus 1 is 2 equals the resultant squared. take the square root of both sides, and my resultant is square root of 2 units. Okay? And you can use the calculator. Again, it doesn't matter if you use decimals or not. The angle, always use tan. Always use tan. Okay, it always works that way. And our reference angle is at our starting point. Okay. So, knowing that, again, you don't have to think about it. Tan theta equals opposite over adjacent. And if we went back to the picture for a second, oops, going the wrong way here. Here's my right angle triangle. Reference angle is always at your starting point. There's your opposite and adjacent, and always works that way. So theta equals tan inverse of 1 over 1. Theta is 45 degrees. So we would say, therefore, the resultant is root 2 units. So this is your therefore statement. And we would say, right. Okay, so now I'm looking, and follow me along here. I'm going right and then up, or you could go east and then north. So I'm going to go right 45 degrees up. And that finishes it off. So there's your therefore statement. All right. I'm going to do another example. I'm going to do it with 3 vectors, and you're going to see that it's not nearly as difficult as it first looks. So the first step is we got to write one of our vectors, and it doesn't matter which one we pick here. So I'm going to take vector u, and I'm going to go here. It's 2 squares long. So there is my vector u. Now, tricky point here, it's a negative. So a negative vector, negative vectors point in the opposite direction. Okay, so that means that vector v, you see how it's pointing over and up? Instead, it's going to go the other direction. So I put its tail here, and I point it in the other direction. So there's my vector v plus w. So w goes at the end of v, and it goes down 2 squares. So there's my vector w. So all I do is, again, vector u, I draw it. V was negative, so I drew it instead of the head there. I had to go the opposite direction, and that's why I drew V like that. Plus W. W goes down 2 squares. There we are. So now our resultant is where we started. That's the tail down to where we finished. So there is our resultant. We need to create a right angle triangle. So I will create it right here. All right, you could have went the other direction. You could create a right angle triangle there. It will get you the exact same answer. All right. Okay. So there is the resultant. So all that's left now is to find the magnitude of the resultant. The height of this right angle triangle, 1, 2, is 3 units. The base is 1 unit. Okay, I have one more example to finish up after this, so I'm going to do it in the next video. So I'll finish this example in the next one as well, and then you're all set to go.